Okay, thank you very much, and I'm really very happy to be here. It's a great honor for me to be at NYU, one of the greatest engineering universities, not only in the country, but maybe in the world. And I'm very humbled here. You know, I did not go to NYU. I went to a New Jersey school, so I hope you, you excuse me for that. Okay, so yeah, as we will see through my presentation, you know, my presentation is pretty much maybe more local than anything else, you know. Like I've been involved with the infrastructure of the nation in my career for many, many years, for the past 37 years. In the area of New York, mostly New Jersey, New York, the metropolitan area. And I was actually a witness of the changes that happened in our small world here in the New York area. So what I figure is that the infrastructure today is being talked by many, many people all over the world. And certainly the United States is one of the biggest centers of infrastructure, as much as the new Silk Roads are in Europe and Asia, et cetera, which the other presenters are talking about. And Jason was very, he did such a nice explanation of what it involves, actually. I think what I was able to gather from my talk today is that in the Americas, starting from the United States, that we actually have like three Americas: the North America, which is the United States, Central America, and South America. It's like a giant of infrastructure on top of two pristine areas down south. And with that thought, you know, it would be almost impossible to talk about the infrastructure needs of the Americas, talking about just the United States, because we would be here for a week talking about this topic. So I just thought maybe I bring you something that happens right within our neighborhood, in front of us, in front of our noses, which is New York. New York, to me, is like such a small sample of the entire world. It's like when you go to a doctor and you have cancer in your body, and he does a biopsy, I think, and he takes a small portion of your body. He can analyze the whole body based on that. I think that's what New York is. So the infrastructure in North America, which will be explained through a New York example, utilizes about 3% of our gross domestic product. The GDP in this country is probably in the 20 million range, or maybe 15 to 20 million, let's say. So it is a good chunk of the GDP will be utilized in infrastructure. But we don't have all the money all the time to address our needs. That's why we keep on talking about investing in infrastructure in this country. While in Central America, even though there are different types of revenues, 5.2% of the GDP probably needs to be employed, of their GDP, not our GDP, their GDP needs to be employed by those countries in their own infrastructure. And that is a big effort for them, 5%. Same thing in South America. Those are pristine, these are like continents that are not developed yet, so that's why the needs are much, much larger. So what I conclude from here is that down south in South America, there's probably a basic infrastructure to attend. In other words, they have to improve their housing, they have to improve their water resources, their wastewater management, etc., as much as the roads. And that is in our version that where you guys live here in these areas, that is probably pretty basic. Then we have a more intermediate infrastructure where countries are already developing railways, ports, airports, canals, etc., to improve our ways of communicating or transporting our goods from one end to another. In number 3, there's a more advanced infrastructure, which involves everything above and much more. It involves more sophisticated things, bigger airports. We need to discover new ways of transporting ourselves. And this is within, I'm talking about just the Americas. I'm not talking about the world, because probably the world is it's very similar, but I'm not touching that yet myself. So even though that the U.S. is a great part of the infrastructure of the world, at the same time, we have to think that the rest of the world, the emerging markets, account for a good portion of the infrastructure also. In countries like Mexico, Nicaragua, Brazil, and Bolivia, they see more and more that their people, the rural people, the ones that used to harvest, all the food that we eat, and we eat a lot of food, you gotta say that, they are coming to the cities and to the centers, the urban centers, more and more all the time. So we have to provide more and more all the time. And that's one of the things that happened in the United States also. Our needs are so great. Our capacity to think for more and develop more. I think you heard from Jason, we were probably the only animal species that wants to develop more and more and more all the time, as opposed to the lion who, he is a king, he's been the king for the past 10,000 years, and that's all he needs, We need a lot more than that, so that's why we are in trouble. I couldn't think of a better picture than this to describe what is actually infrastructure. There you go. It is everything. It is a crowded map. The map is full of it. You have from the transportation, the surface transportation, you have the airports, you have the trains, you have the water, you have the wastewater, you have the energy infrastructure, electricity and gas, and you name it. We managed to crowd this country with infrastructure for the past 50, 60 years, maybe more. No, maybe more than 60. I'm thinking about, maybe for the past 100 years, let's say. We managed to jam up this country with so much infrastructure, including the federal highway system that was just started, let's say, in the late 50s, 60s. We managed to do so much that now we have to fix it. We have to improve it. We have to provide something new. And we have to continuously do this because why? For the same fact that I just talked before, that we always need more. The American Society of Civil Engineers makes a report card every 4 years, actually. And a lot of real smart engineers work on it for 4 years. And this is based on the report that came out in 2013, because the 2017 hasn't come out yet, so I couldn't use any of their numbers, but I had to go back to 2013 at least, which is applicable for many years. But they think that this country needs about $3.6 trillion to attend to our needs by the year 2020. You imagine what $3.3 trillion is? It is an enormous amount of money that we need to be able to maintain our infrastructure, to just continue our life the way we know. And if you allow me to just put this chart in front of you, infrastructure in this nation is composed of these things, according to the American Society of Civil Engineers. And since I'm an engineer, I believe on them. It talks about surface transportation. It's one of the biggest components of infrastructure. Water and wastewater infrastructure, electricity, airports, inland waterways, and marine and ports, and dams, and hazardous waste, and levees, and public parks, and rails, and schools, and even housing. At times, not here. But all of these are the components of our tremendously dense infrastructure from the map that I just showed to you. And this will necessitate lots of dollars to attend. And I have to say, if we don't have the money to spend in our own country, I don't know where are we going to spend if we have to go outside from our country. We probably need about $7 trillion. I hope Mr. Trump, when he talked about his investment of $1 trillion in infrastructure, he knew what he was talking, because sometimes he doesn't know what he's talking about. On the left-hand side of this chart, you will see the total needs up to 2020. In the center, in the middle row, is the estimated funds that already are allocated for infrastructure. And on the right-hand side is the gap. So from 3.6 trillion at the bottom of the total, you have 2 billion that are already allocated by our country. You need 1.6 trillion more. So Mr. Trump, when he was talking about his $1 trillion investment, I hope he was not talking about on the funds that are already allocated, but he was talking about of new money. And that was the hope I have, because if that happens, we probably can fix our roads and the things that are decaying little at a time, the dams and the levees that are like collapsing as we speak. I hope he was talking about that trillion to add to the $2 trillion that's already allocated. If we don't do anything, there will be serious consequences for us. We will lose, number one, 3.1 trillion in our GDP, which that would be really something. $3,100 could be lost per household in every household of the United States. And 3.5 million jobs could be lost. And we're not in the business nowadays of losing jobs. We're in the business of producing jobs, as I understand. Therefore, New York, which is the example that I just brought it to you on what infrastructure actually does and works on a daily basis. I brought you a picture of the Hudson rail yards. It's an area of New York City that you are probably very, very familiar. It's between 34th and 30th Street to 38th Street or something, 10th Avenue to 8th Avenue. It's a big, long area where the railroads used to pass by, and a lot of rail lines are converging here. Some may be going to Grand Central, some may be staying there to wash the cars or to maintain or to do some work on them. But it was a very nice area. This area is going to be covered by a big, by a thick, I should say, deck slab made out of concrete, in which they'll be able to build buildings on top of it, which are already going. About 5 or 6 buildings have already been built, about 70 stories, 80 stories. And a lot more is coming until you see the picture on the other side. Everything's going to look like high-rises. But that will take care of the infrastructure on our houses that we need in this area, shops, and anything related to housing or to offices, etc., that are bad. They seem to be badly needed because they continue to be built. So this is yet something that happens right in front of us, and this is part of the infrastructure too. This will require that the water supply be adequate. The transportation means will have to also attend all these extra people that will come up into this area when we build this. So we continue building. We have to continue to provide things that belong to the infrastructure sector. The TAPPAN Bridge is another project that you know very, very well. It's a nice infrastructure project that happened. It started about maybe 3-4 years ago at a cost of maybe $4.5 billion. And the TAPPAN Bridge spans from Rockland County to Westchester County. It provides a very, very vital access point in this part of the country for vehicles. The original TAPPAN, I think, was built maybe 50, 60 years ago. The lifespan of the bridge was probably no more than 30, the design lifespan was more than 30 to 40 years. But it lasted more than that, almost double the lifetime of the design lifetime. Now the new TAPPAN Bridge, attending this, making a better use of their infrastructure money, they made it to last 100 years. It's probably a smart thing to do. And it's a faster and smarter way to use our infrastructure money, because money right now, you could see, is not very, very plentiful. So they're making this bridge 100 years lifespan, which means they will probably be utilizing the bridge for the next 150 to 180 years easily. Maintenance will always be there, so they will always need money for maintenance, but there's other economic factors there, like users pay, whatever, is probably going to take care of that. And yet another example of another infrastructure project that happens to be decaying in our country and that we need to attend to is the LaGuardia Airport. The rebuilding of the LaGuardia Airport is an infrastructure project that just started, and the cost of this project will be about, I think, close to $7 to $8 billion to start. By the time they finish, could last, it could be about $10 billion. And this airport was dedicated in 1964, so it's just going to be about 60 years, and it needs to be upgraded. It doesn't fulfill the requirements of an airport anymore. It is really it was a good idea that when they thought about this airport, because this airport is one of the three major airports in the tri-state area that provides services to the people, and when it's finished, it's going to be almost equal to Kennedy and Newark Airport. So it's going to be done in three phases. This project is going to be done in three phases. I'm sorry, in two phases, but three terminals. The first terminal in phase one is going to consist of the construction of Terminal B, which is kind of in the center of the airport. And Terminal B, I'm sorry, just to let you know, the phase two is going to be obviously Terminal C and D, as you just saw already. So Terminal B is going to look like this, more or less. In the background, you see Grand Central Airport. Then you have the central hall that goes from one side to another, and then you see the gates for the different planes that are going to land in that part of LaGuardia Airport. This is the location of LaGuardia. The red thing is LaGuardia. It's about 25 miles from Kennedy, which is the other red point on this side, on the right-hand side. And it's also another 25 miles from the other side, which is Newark Airport. So it's like a sort of a triangle. So it's located strategically in that area because all three airports must attend the millions of passengers per year that come through our New York area. And again, this is Terminal B. As I show you, a little bit of a close-up. On the bottom of the picture is one of the hallways, how the hallway is going to look like when you walk before you get to your gates. And that's another look from behind. That's how the Terminal B on LaGuardia Airport will look. They will also do some new improvements in the transportation, which is another section of our infrastructure. That there may be Grand Central Parkway being beefed up and realigned, etc. And then they also plan to bring a light train that will start, I think, it's going to connect to the number 7 train. That's one of the versions. So you'll be able to get to LaGuardia Airport by road, or you'll be able to get from Manhattan, taking the number 7 train to the light train into LaGuardia. Those are the plans so far. This job is not built yet, it's being built. It's a design-build project. In other words, as the job is being built, is being designed at the same time. It's one of the modalities in project delivery. You know, the design build is one, design build is another one. This is a design build, and the PPP, which is the private public partnerships, is the other modality. This is being done by a contractor and a designer, and like I say, things are being designed as they're being built. And then you have Terminal C and D that are going to join B now. C and D used to be the Delta Airline terminal that decided to join now the thought of making a new airport, and they tried to make a unified airport by building now the three terminals. And obviously, when the idea again is to have an airport that resembles Kennedy or resembles Newark Airport. There we go. They have all the unified terminals, buildings, building a state-of-the-art airport. LaGuardia Airport will look really, really cool, like in the picture. This is only a rendering, but it will serve, you know, the needs of our tri-state area in this section of the infrastructure, which is airports. And this is the central hallway. It will look like this. It will run from one end to another. So you will be able to walk now from, right now you cannot walk, or I don't think you can walk from B to C. You may probably have to take some kind of a bus or something, but now you will be able to walk from one end to another. It will be a very, very modern hallway that will join all the three terminals in case you have the need to go from one end to another. Well, that was a very very upscale infrastructure, the type that happens in our country, and the type that consumes billions and billions of dollars, perhaps trillions. We said trillions, definitely. In the meantime, a little bit down south in Central America, the picture is a little different. While in North America, we're looking for financing or getting a point of revenue, or having the government to subsidize or allocate from our general budget or GDP, etc., so much money to do all the things that we described in terms of electricity and water and this and that. Other countries don't necessarily have the same. And they are so close to the US that you say, why not? Because for some reason it's not like that. This part of the continent, as well as South America, they are pristine continents. They haven't been developed. And all the Americas, as you remember, it was only discovered in 1492. When Columbus made a mistake, he didn't have his GPS, and he followed the wrong route and stumbled at a stopping point, which was the Americas, and discovered this continent only a few hundred years ago. Not like China or the Arab countries or the old world, Europe, that was there for thousands and 5,000, 10,000, God knows how long. Well, the lands were here also at the same time because this was part of Earth. But the peoples were never there except the natives that lived in this country. So these countries are very pristine countries. So when they think about an infrastructure project, it is a real big deal, you know. While we worry about in the United States to allocate or reallocate maybe budgets from infrastructure, and maybe can we take something from the military maybe and take it into infrastructure, God knows how can the government reallocate their monies if we ever need it. These countries are not like that. This is a big deal for a country like Nicaragua. And what they're trying to do, they're trying to build another Panama Canal of a different nature, but similar to Panama Canal. Their idea that they had, and this, the Chinese government has helped out tremendously in doing the first studies and coming up with the, with the concept of what can they do. Can they actually bring another source of passage from one ocean to the other in the same part of the world, which is Central America. Remember, Panama Canal is just about a few hundred miles, a few thousand miles maybe from Nicaragua. Can they afford to have another one? But so they think it should work. This is a canal that will go from the Pacific Ocean into the Caribbean Sea. They will have the port of Brito and the port of the Punta Gorda, I think, is the other port that they want to join, and therefore traverse this part of the world. Over 260 kilometers long, they're planning to do 30 meters deep, which is, I think that is, it's a big thought, I think, 30 meters deep, and 200 meters wide canal. That's definitely much wider than the Panama Canal in itself, So with this type of an arrangement and the way they have it aligned, the alignment of the canal, they think that they could pass boats at pretty much higher speed than Panama, number one, and they could accomplish the same effect that Panama has with the cargo shipping. But 260 kilometers is a lot. I think the Panama Canal traverses only maybe 70 or 80 kilometers. So it's quite a lot long. But being wider and being deeper, it probably will handle the biggest ships in the world, they think. So it was an easy engineering. You know, the engineering was nothing. It was almost there because they basically used the same concept as the Panama Canal. Lake Nicaragua, which is the bigger lake in the center of the country, which covers a good chunk of Nicaragua, is at a higher elevation than the Pacific Ocean and than the Caribbean Sea. So you have the oceans here and you have the lake here. You just have to have the boats going up. They already have the engineering know-how on how to do that. They're going to be using two locks. One lock is going to be here at the port of Brito on the Pacific side, and the other one is going to be the lock on Camilo, on the Camilo side. So they have these locks that they're huge, huge pools of water that they will bring the boats. They will fill up the pool. The boat will rise up with the water. They will fill up another pool, the boat will rise up, and they will rise up. As they fill the pools, they will reach the elevation of the Nicaragua lake. Once they do that, they'll traverse the Nicaragua lake. And the Nicaragua lake, by the way, is not that deep, but they need to make it deeper. So that's the problem. And they will continue going on the canal, and then from that elevation, they will have to come down again by means of another set of locks. So the water will like be discharged one time in steps, 2 times, 3 times, and as they discharge the water, the big ship will also come down in elevation and will reach the ocean again. It's an easy concept, am I right? When they first built the Panama Canal, I don't know why they didn't think about that. The French people, they thought about just making a big trench from one end to another, and they lost millions of lives trying to do that until the U.S. Army Corps of Engineers, in a very ingenious way, came and actually invented these locks in the way to bring the boats up and the way to bring the boats down. That was like the American ingenuity is like amazing. I mean, it's second to none, I gotta say that, without any doubt. Anyway. So this is the same concept. So this is a little bit of a look on the locks. I'm sorry, this is in Spanish. I took this picture from a Spanish magazine but I thought it was cool to show you. The elevation of the ocean is on one side, and the elevation of the lake is on the other side. The locks are in the middle. They are these electronic locks that they close the pools from one side to another. They fill up with water. But they need water. They need a lot of water, and they need to have a constant supply of water. It could never end, because if that supply of water ends, they'll stop. They will have to put a red light and stop the traffic. You don't want to stop the traffic in the canal. So they're bringing water from rivers, nearby rivers, that they will supply water constantly to these locks, so they will have a constant mechanism to bring the boats up and down. Okay, what are the challenges to do this? You know, it seems like there's no brain. It doesn't take much brains to do this, no. As I was telling to somebody, the engineering part is the easiest part. It's done. Engineers somehow, and you guys are going to be engineers or computers or computer majors, etc. Anything is solvable, right? You give me a task, we'll do it. You want to go to the moon, we'll go to the moon. We want to do a flight to Mars, probably very soon. We might be getting, although that's a little bit difficult. You want to invent a new mode of transportation. Mr. Musk, Elon Musk, comes up with a hyperloop. There we go. You know, we're going to go 760 miles on land. An hour? Yes, 760 miles an hour on land. We'll traverse from New York to Washington in half an hour. You'll probably be gonna be able to work in Washington, and Jason will be happy to come back every day. Half an hour trip, right?
It's not half an hour right now.
It's not half an hour right now. So that type of an ingenuity exists. And if you read about the Hyperloop, to me it's a fascinating mode of transportation that if it happens, it's going to revolutionize our way of living forever, forever. Nobody's going to want to get up on a plane anymore, or nobody's even going to want to go on a roadway because it's going to be too slow. So they're going to take the Hyperloop everywhere. To me, that's probably the thing of the future, that if it ever happens, listen to me, if it ever happens, your lives are going to be totally different, just as much as your lives are different now than the lives of the person from 1930 or 1925 or 1910. We live in a different world. Same thing. Anyway, so these challenges in engineering are real no challenges. You can solve almost everything in life. What you cannot solve is the other challenges. The environmental, you cannot solve. The population, the people that live in the continents, trying to change their lives. Those are the difficult things to do. And Nicaragua is having a big problem in building this simple canal only because it will involve probably the death of the Nicaragua lake, because of the traffic that's going to go there, because they're going to have to dredge the lake. And as you dredge and the time passes, it's going to get siltation again, back again. So it's going to be a constant environmental problem for them. This is some of the environmental issues that they're going to have to go through, digging into Lake Nicaragua to pass these big boats like you see in here, or just maybe getting rid of the animals that they live there forever, and the fauna, the flora, etc. The environment will not look like this ever again. So people are having second thoughts about this. Not the government, the people that live there. Nicaragua will also suffer from their natural reserves. Some of them are on land that they have to dig this big canal, and they have to destroy very pristine ecosystems. The natives will lose their environment. Right now, they are fishermen, and they fish in this lake, and they live from there. This will be gone forever. It will become like the Hudson River. So therefore, the people are protesting right now. So the actual canal has stopped for a while. The concept is there, but they don't know if there will ever build this infrastructure project in a country like Nicaragua. Okay, from Nicaragua we go down to South America on a different thing, which is also simple, and this is probably one of the three situations that I explained before. There's a simple infrastructure. This is a simple infrastructure. Building a railroad. How much simpler can that get? It was built since 200 years ago, railroads. So therefore, let's build one in South America, and let's bring people or goods or whatever from one side of South America, on the eastern side in Brazil, to the western side in Peru. That's going to be another Panama Canal. This is going to be a third way to go to bring goods from Asia, from Japan, from whatever into the Western world, United States, etc., etc. So they had a big idea. Wasn't bad. They thought about it. Again, the Chinese government started to help this idea, but at some point they abandoned, perhaps for the political reasons. Like I say, not the engineering is easy. It's the other factors, the people, the environment, etc., that stop everything. So the Chinese abandoned the program, but it was taken over by the Germans now. But Germany and Switzerland, they took it over, and they made actually a letter of intention with the governments of some countries in South America, and it's they are very close to start this project. I think the financing is there also. It's just a matter of putting a little bit more effort in trying to have 4 or 5 different countries together with the same thought, which is the other part that is also hard. You cannot have the world convey in that way. You can always solve problems. You cannot have 280 countries thinking together and make one thought process altogether. That's the problem. So this train is going to traverse about 3,000 360 kilometers over in South America, and it's going to go through, like I say, 4 countries that I'm going to show you. This is just a picture of South America. This actually came from it's a picture from the Silk Road project that I thought it was appropriate to bring it, just to show you that well, I don't have anything to. But on the right-hand side, on the lower, right in the middle, is the port of Santos in Brazil.
São Paulo.
Yeah, Sao Paulo. That's one point of entry, and the other point, the other end is right almost just across in Peru. The port is Ilo. So the idea was to bring commerce. Not only Brazil is also interested because they have a big commerce with everybody else, and they also want to bring their goods into the United States, et cetera, et cetera. But also, it was mainly to bring goods from China and Asia and Japan, all the Asian countries that are constantly moving goods from one continent to another. So this picture just was brought here to show you the location. But the 2 alternatives and the 2 alignments that have been considered are here. One is in red, let's say the southern alignment, and the other one is in green, is the northern alignment. The original idea for the bioceanic train was to build first the northern alignment. That would have involved only construction of the railroad in Brazil and then Peru, and perhaps go down to Chile, but not yet. Just Brazil and Peru. That was one alternative. The alternative that the Germans and the South American countries have considered more favorable is the southern one, the red one, that goes from Santos, which is in big red there, to Ilo, which just crosses directly on the center of South America. I'll tell you why, what happened. The reason the red one was considered a better solution is because the green concept was meant to go through a very, very delicate area in the Amazon, while the red one was going to go on a very, very delicate area on the Andes Mountains. And just, I know it's a little bit of rushing time, but I'm just going to show you maybe the last picture of what the 2 alternatives involve. The first one was going to go through the Amazon jungle, which is the first picture on the left, on the top, going through the Amazon rainforest and the Amazon River, and that really is like a big task to take, a big, big task to take. Despite everything, I mean, an environmental impact statement on this area would be really, really, the volume of it probably will have to cover like a whole entire room of paper. It will have to be done in a number of years, just the environmental impact statement to clear up all the things that are happening. While the other one is going to go through the mountains in areas that already have a railroad line. So that's why I think the German government has decided to help out these countries in building the southern route rather than the northern route. And probably that's the one that's going to happen on the bioceanic train. And if everything works okay, by 2023, it will be finished. Thank you very much for everything. I just wanted to show you, I'm sorry, I just wanted to show you that the 3 different types of infrastructures that you have to consider when you consider infrastructure, how different they are, how different they could be. Okay, thank you so much.
Thank you, Professor Pozotrigo.